Okay, so binomial expansion. So binomial means two terms and expansion means we're trying to expand the bracket. So it's going to look like something like this, a plus b in brackets to the power of n. And you got a and b, they are two terms, binomial, and n is your power. And we want to expand it. If we look at a simple example, x plus y bracket squared, you know, with FOIL or whatever, it's going to be x squared plus 2xy plus y squared. Then if we try x plus y cubed, then you know it's going to be, you're first going to take your x plus y squared, put brackets around it, then multiply it by another x plus y. And so you have to do it, multiply each term by x cubed, to x cubed y, and xy squared. So you've multiplied everything by x. Now you have to do the same, but multiply everything by y. So you get x cubed y, 2xy cubed, and another y cubed to finish. And then what you need to do is you collect the like terms and to simplify. So the x squared and the x squared y and the x squared y match. So you add them together. Yeah, those match. So you add them together. And you've just got a y cubed on the end. And now if I just do x plus y 4, we won't do it manually, I'll just tell you that I know it's going to be x to the 4th times 4x cubed y plus 6x squared y squared plus 4x squared y cubed plus y to the 4. And now we'll explain how you can just do that automatically. And so if I just quickly do x plus y to the power of 1, that's just going to be x plus y. And if I do x plus y to the power of 0, that's going to be 1. Because anything to the power of 0 is 1. And anything to the power of 1 is itself. So if I just sort of draw out all these results, the first thing you'll notice is with each row you add, it becomes wider, which makes sense. So there'll be a few things that you notice. The main thing is you got two things you want to notice, two patterns. And these are fundamental to the formula that you get in the book. So you want to have a look at the coefficients, and the coefficient is just the number in front of the letter, and the letter is called a variable. And you also want to recognize the ascending and descending powers. So if you have a look, if you go from left to right, you'll see that the x powers decrease. So it goes from x to the 4 to x cubed, etc., etc. But the y power increases. And another thing and then if we look at the coefficients, you have to imagine your imaginary ones when there's no number before it. So yeah, you're looking at 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Hopefully that is a bit familiar to you because those coefficients come from something called Pascal's triangle, which we can draw out here. And hopefully you can see how you get that. And that plays a big role in combinations in terms and coms. Important to know that when you're in Pascal's triangle, each row you count from 0, and each number left to right you start at 0, then 1, and then 2, if that makes sense. And then we write it in this notation, NCR, or in this way, which is probably the one you're going to use when you do binomial expansion. It's just a bracket, then the N on top of the R. Now, why do we have this combinations formula suddenly cropping up here? Well, if you notice a third thing, if you add up the power of x and y, it's going to add up to your n. So if we take the example of when we're trying to do x plus y to the power of 3, every time you've got x squared, you've got x cubed, 3 plus 0 is 3, x squared y, 2 plus 1 is 3. And so, but each time you're pretty much changing the number of x's you're using. And so, the way to think about it, okay, how many, for example, if you're trying to do x squared y, how many ways, I've got a total of 3 x's I can use, how many ways can I get 2 of those x's? And remember, order doesn't matter, so that's just 3 choose 2. And the reason why it's symmetrical, because that's also the same thing as saying, oh, how many y's can I use, or how many x's can I not use, which would be 3 choose 1, and that's why you're getting it symmetrical as well, if that makes sense. Now we can move on to a generalized formula of your a plus b to the power of n. And so if we just kind of start off, you know you're going to start with your n and you choose 0 because you start at 0, then you go up 1, 2, 3, all the way to n. And then that's going to be multiplied by a to the power of n at the start. And then you're going to get b times to the power of 0. And just trying to, and remember, you're working your way along the Pascal's triangle. So then the next one's going to be then you get your n choose 1 times a to the power of n minus 1 times b to the power of 1. You see the a's decreasing in power, the b's increasing in power, and so on we go. And the final term will end up being n choose n times a to the power of n minus n multiplied by b to the power of n. And remember, a to the power of n minus n is a to the power of 0, which is 1. And now we use sigma notation to get that formula. This is a capital sigma. And on the bottom, and we generally use k, that's convention. And on the bottom, we do k equals 0. See if I see I'm writing up here, you can also write your combinations as nk or n choose k. So k equals 0, and then k equals n. Now, the one on the bottom that's your start value, and then the one at the top is your stop value. And so it's basically telling you, okay, evaluate all of these things given the values I'm giving you, and k is varied, and you do all of them for k equals 0, then 1, then 2, and 3, all the way up to n, then you add them all up. And so that's why we're getting our a to the power of n minus k times b to the power of k. Because that's what we're doing in that long one there, you know. K starts at 0, b to the power of 0 is up there, you know. Hope that makes sense. So that's the formula that you'll get in the book. So let's try it with an example. A simple example, but still an example. 1 plus x all to the power of 5. So 5, choose 0, and we multiply by 1 to the power of 5 times x to the power of 0. You know, and to be precise, we're doing 5 minus 0. Our n is equal to 5. Our k starts at 0. Then we're doing 1 now. And the next one will be 5 choose 2 times 1 to the power of 5 minus 2 times x squared plus 5 choose 3 times 1 to the power of 5 minus 3 times x to the power of 3, and then 5 choose 4 times 1 to the power of 5 minus 4 times x to the power of 4 plus 5 choose 5 times 1 to the x to the power of 5 minus 5 times that. Oh dear, I've made a mistake there. That should be a 1, not an x to the power of 5 minus 5. But yeah, and then 5x. Remember, well, our 1 is just a constant, so you can't see the powers decreasing, but it is. And then as we go along, the x powers are increasing. And then if you're not sure on the values for the Pascal's triangle, just type it in your calculator. You may have to click shift, but that's fine. And then so 10x cubed, then 5x to the power of 4 plus x to the power of 5. And as you can see, yeah, that's, you got an invisible x to the power of 0 there. And then you got an invisible 1 as a coefficient there. And so as you can see, it's matching Pascal's triangle. We didn't actually do row 5, but if I just do that quickly, see 1, and then you add them together. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1 there. And as you can see, as I said before, your x powers are increasing, and then your powers of 1 are, in a way, decreasing. It's a bit invisible, but yeah. So yeah, once again, and just to remind you, this is following Pascal's triangle. I hope this example has made the general gist of binomial expansion clear. I'll record a second video for more problems.